everybody, and welcome to Math After Hours. Tonight we are looking at homework 3 rectangles. So remember, you only had to do the odds for these. So we're only looking at a few questions. So the first thing I want to do is make sure we remember the properties that we learned of a rectangle. So there were two new properties. The first one was that the diagonals of a rectangle were congruent to each other. So remember, if we combine that with the property of a parallelogram for the diagonals, which was that they bisect each other, that meant that for a rectangle, all of the inside sections of our diagonals were going to be congruent to each other. And the other property that hopefully you guys know already is that the angles are 90 degrees. And then also keep in mind that a rectangle is still a type of parallelogram, so we're still going to be using those properties. So let's get started with number 1. So number 1, we are looking at the sides and the diagonals. So the first thing is that we can fill in some of these sides. Remember that since the rectangle is still a type of parallelogram, the opposite sides are still going to be congruent. So we can get that WX is 19 and that VW is 31 since they're opposite each other. So I'm going to fill those in over here. So we have 31 and we have 19. So then the hard part is figuring out these other 3 lengths. Okay, so those 3 deal with our diagonal. So I'm just going to highlight them, but I don't think I have a highlighter on here. So I'll just use a color. I'll use this green. Okay, so YW is this whole length of our diagonal. And then ZX is this other, just that one section, and then VX is the whole other one. It's this whole other one. Okay, so one of the new properties of a rectangle is that the diagonals are congruent to each other. So that means whatever we get for WY and for VX, those should be the same numbers because they're both a diagonal, so they should be congruent. So now what we have to figure out is how can we get to those diagonals? Well, we have to remember that these angles are 90 degrees and we have our side lengths. So what we can do is split that rectangle into a triangle. So I'm just going to draw one triangle, and that should be good enough to see what we should be doing. So we have a 90-degree angle up there at V, and then we have side lengths of 19 and 31. So we're trying to find this third length. Well, when you have a right triangle, remember you can always use the Pythagorean theorem. Just remember the triangle has to be a right triangle in order to use the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. And A and B represent the legs of your triangle. And then C is your hypotenuse. So this side right here is C. And your hypotenuse is always the one that's across from that 90 degrees. You could also say it's your longest side, but technically it's across from that 90-degree angle is your C. So for right now, we're going to be looking for our C. That should be the diagonal. So A and B are 19 and 31. So we're going to have 19 squared plus 31 squared equals c squared. So now I'm just going to solve algebraically for c. So at this point we need to get c by itself, so we need to do the opposite of squaring, which would be taking that square root. Just like if you had 2x, just as a side note, 2x equals 14, you would divide by 2 to get x by itself because 2 is being multiplied by x. And the opposite of multiplying is dividing. So here we want to take the square root of both sides, since the opposite of c squared is the square root. And that cancels it out, so then we get that c equals the square root of 1,322. And I'm going to round that to 3636. So that means that WY or YW is 36.36, and since our diagonals have to be congruent, it also means that BX is 36.36 also. So if all of these diagonals are going to be congruent to each other and they bisect each other, remember bisect means it cuts it in half. So ZX should be half of VX. Well, half of 36.36 is 18.18. So we used some properties from a parallelogram that we've used in the past, and then we also used some new properties of a rectangle, like the 90-degree angles helped us use the Pythagorean theorem. So we kind of, for these, have to pull from multiple things, just like when we look at number 3, which we're going to look at now. Number 3 deals with angles, and we have to pull from a bunch of different resources for these. So what I'm going to do first is I'm just going to go through and I'm just going to circle the angles that I know are congruent in different colors. I'm not even going to start solving for a number. I'm just figuring out what angles are the same first. So I'm going to start with this 59 degrees. So if this is 59 degrees, then I know that angle 3 also has to be equal to it, since a rectangle is still a parallelogram. These two angles would be alternate interior. And then also angle 1 and 3 are congruent, since these diagonals are all the same. That means we're dealing with a isosceles triangle, so that in an isosceles triangle your sides are the same, those base angles are also the same. So I could say 1 and 3 are equal, so that also means that 6 is equal. So I have that these 4 angles are going to be equal to each other. So then I could also say that the other 4 angles that are on the outside are going to be equal. So 2, 11, 4, and 5 are going to be equal to each other for the same reasons. They're alternate interiors, and they're the base angles of your isosceles triangle. And then we have these inside angles, and we could say that 8 and 9 are going to be equal because they're vertical angles. And then last but not least, I have that 10 and 7 should be equal for the same reason that they would be vertical angles. So now let's try and get some measurements in here. So I'm going to do the blue ones first because they're the easiest. So since this angle right here was 59 degrees, all of the other blue angles are also going to be 59. So now let's try and get those green angles. Remember, the one property of a rectangle is that the angles are 90 degrees. So if we already have, for these two angles right here I'm looking at in particular, if I already know that this is 59 degrees, I could get angle 11 by subtracting it from 90, because I know that the measurement of angle 11 plus 59 degrees should equal 90. So if I subtract 59 degrees from it, I can get my measurement of angle 11, which ends up equaling 31 degrees. So then all of my other green angles would also be 31 degrees. So 2 would be 31, 4 would be 31, 5, and then of course we said that 11. So now I'm left with my inside angles. So what I'm going to do, just like I did with 1, I'm going to separate it into a triangle, but now I'm going to just look at one little triangle if I separate my rectangle into 4 triangles. So I know that 4 and 5 are 31 degrees. So I'm just going to write 31 in here so we could see this. So I'm trying to find this angle up here. I'm trying to find angle 7. Well, we know that the sum of the inside angles of a triangle should equal 180. So your two bottom angles that are 31 degrees, if I add those together plus angle 7, it should equal 180. So I'm going to add these two together. 31 plus 31 gives me 62 degrees. And I'm going to subtract it from 180, and that'll give me what angle 7 is. So I get that angle 7 is 118, which also means that angle 10 is 118. So you could get angles 8 and 9 in the same way. You could look at your triangles on the left and right and add those two congruent angles together and subtract it from 180. Or if you look at, say, 7 and 9, those two angles are supplementary to each other. So remember, supplementary are two angles that add up to 180. And if you remember the story, supplementary are bigger angles because guys are bigger, so they go up and they say, "Sup, what's up, dude?" And girls are smaller, so they go up and they complement each other. So the complementary is 90 degrees and the supplementary is 180. So angle 7 plus angle 9 should equal 180. So if we subtract the measurement of angle 7 from 180, then we get the measurement of angle 9. So we get that angle 9 is 62 degrees. So this problem involved a lot of different things, okay? We had to remember our alternate interior angles. We had to remember that in an isosceles triangle, since the sides are equal, those opposite angles are also equal. We had to remember supplementary angles. So there's a lot of different things that you had to remember in order to work this problem out. So remember, these things are never going to go away. They're going to haunt you forever and ever and ever. So now that that's really depressing news, let's look at problem 5. Okay, so 5, I'm going to kind of do the same type of thing. I'm going to try and fill in the information that I can figure out first. So if this angle up here is 126, I also know that where this M is written is also 126. And if you think back to problem 3, if this angle right here is supplementary with 126, I can subtract it subtract 126 from 180, and I can get that measurement is 54. So we have some of these inside angles. Well, how could we get those outside ones? Well, remember that these triangles on the inside are all isosceles triangles. So your base angles have to be the same. So since a triangle has to equal 180, if I subtract 54 from 180, what I'm finding is the degrees I have left. So I have 126 left. So between these two angles, they have to add up to 126 degrees, because otherwise my triangle won't add up to 180. If it's anything less than 126, you can't make a triangle. If it's anything more, there's too many degree measurements in there, so again, you can't make a triangle. Well, so hopefully we established that these two angles added together have to equal 126. So the question is, how do I know which one it is? Because couldn't one angle, say, be 100 and another be 26 degrees? That adds up to 126, right? But remember we said that since these diagonals are all the same, these base angles right here and right here have to be the same. So for the base angles to be the same, they have to be the same number. Well, for it to be the same number, I'm going to divide 126 by 2, and that'll get me the same number. So these two base angles here have to be 63 degrees, which does end up adding up to 126. So this side is also 63 degrees, okay? And since this angle at the top and bottom are 126, I use the same theory so that they also have to be 16 degrees. You could also think about it in terms of your angles, and this just looks like a hot mess now, but the angles of your rectangle have to equal 90 degrees, so you could always say 90 minus 63 gives you 16 degrees, and that's how you could get those other angles. So I'm just going to fill these in then now that I have everything. So J, M, K, J to M to K is going to be 54 degrees. J to K to H is going to be 63. HLK, it's just the whole angle of my rectangle. It's an easy one, it's 90. H, J to L, 16 degrees. That kind of looks like 160. That's a really big degree sign. I find that some people have trouble figuring out which angle it's asking for. So one thing you could always do is kind of drag your pen along where it goes. So for instance, this one's asking for LHK. So if you just put your pen on L, and I'm going to actually make a green mark so you could see it, but you guys don't have to on your paper. I'm just going to start at L, and then I'm going to go to H, and then I'm going all the way down to K. So the angle it wants is the one in between those two sides. So it wants 63 degrees is what it's asking for. Same thing for the last one. If I put my pen on J, and then I want to go to H, and then to K again, it wants the angle in between those two sides. So it wants that 16 degrees. So I find that some of you get those angles that they're asking for mixed up. Okay, so let's move on to 7 then. Okay, so 7 starts to look at algebra. Well, actually 6 does, but we're only looking at the odds. So we're starting with 7. So the first thing we got to figure out is, what is it talking about here? So SQ is one of our diagonals, and PR is our other diagonal. So if you remember the properties of a rectangle, it says that our diagonals are congruent. So since the diagonals are congruent, we're going to set our equations equal to each other. So let's set those equations equal to each other. 11x minus 26 equals 5x plus 28. And then we're going to solve algebraically. So remember, there is brick wall down your equal sign, and you want to do the opposite what it has there. So this is a positive 5x, so I'm going to subtract it. So that I get 6x minus 26 equals 28. And when you're solving algebraic equations, you could always picture it like it's a swing. So we took the 5x to this side. So just like a swing, when you swing you go forward and then you got to come backward. So then we want to take our constant, that 26, over to our other side. So whatever you take forward has to go backward. So we're going to add that 26. Since it's being subtracted, we want to do the opposite. So then we have 6x equals, sorry, it's being subtracted, so you want to add it. So we have 6x equals 54. And then the opposite of multiplying is dividing, so you want to divide. So then I have that x equals 9. And then, did we answer what it asked? Nope, because it said to find PR. So it gave us that PR equals 5x plus 28. So all we have to do is substitute that 9 in for that x. So we would have then that PR equals 5 times 9 plus 28. Which would be 45. So then PR equals 73. We're done with 7. So 7 used the rectangular property that your diagonals are congruent. So let's look at 9. We are almost done. Positive thinking. So now let's look at 9. So 9, I'm going to first highlight what they give us. So they give us LO. I want it in a color. Okay. They give us LO. And they also give us QN. So when you guys solve these problems, don't look at the end and see kind of what you're trying to be solving. Look at what they give you first. It's kind of like if you're cooking and you're the kind of chef where you just kind of throw things together and see what happens, you're not going to look for the end result first. You're going to see what you have and see what you can make from it. These are the same type of ways. You want to see what information the problem gives you. So this problem gives us the whole diagonal, and it gives us half of the other one. So let's figure out how those two relate to each other. Well, since the diagonals bisect each other and they're also congruent, we know that LO is going to be double what QN is. If you think about it, just as a side problem so you guys can see it, I'm just pulling random numbers so you guys can kind of see where I'm coming from. So this is kind of like a totally separate problem almost. So if I know that this side, let's say, is 6, okay, well, all of my other small sections are going to be 6. This side is 6, this side is 6. And now I just made it look like the devil. But that's okay. We're just going to keep going. That was kind of a bad number to choose with bad colors. That's kind of, I'm going to throw yellow in there to make it look happy. So that means this whole side here is going to be 12. Well, you could get the whole length if you just doubled 6. So you could say 6 times 2 gives me 12. So multiplying half of my diagonal will give me the whole length. So we're going to do the same thing here, just with equations. I'm saying that if I double Qn, so if I multiply Qn by 2, it's going to give me LO. Just like here, I multiplied by 6 and it gave me 12. So I'm saying 2 times 10x plus 2 is going to equal 15x plus 19. So the first step to solve is you want to distribute that 2. So then we have 20x plus 4 equals 15x plus 19. Now it's just like any other equation we've been working with. So I'm just going to go ahead and solve it through. So remember, first you want to combine your like terms. So you should get that x equals 3. So now at this point we could try and see what they're asking us for. So they're actually asking us for Pn. So they want the whole length of that other diagonal. They want this whole diagonal here. So there's 2 ways you could do it. Just depends what way you see it best. So what I mean by that is you could either plug it into LO, and that would be your straight answer since the 2 diagonals are equal. So I'm going to do it that way. So you could say 15 times 3 plus 19. So that's LO again. So 15 times 3 is 45. Plus 19, and that gives you that LO is 64. So remember, the diagonals are congruent, so that would also be your length of Pn. The other way you could do it is substitute it into Qn first, and then double it, just like we did here. We multiplied by 2. So 10 times 3 plus 2 will give you 30 plus 2, which will give you 32, is Qn, and then, that's a wacky n, and then if you double it, you get 64, which is what we got before. So there's 2 different ways you could plug it in or solve for it. So then let's move on to look at 11. Scroll down a bit. So 11 and 13 are looking at our angles now. So for 11, if this angle right here, GHJ, so I'm shading this one in, is 5x plus 8, these two then, h, j, I, are going to be congruent for the same reasons that back on 3 we were able to fill in some of those missing measurements, because since a rectangle is still a parallelogram, these would be alternate, sorry about that, these would be alternate interior angles, so that they would both be equal. So since these angles are both equal, we can set the expressions equal to each other. So I can say 5x plus 8 is equal to 7x minus 16, and then solve algebraically. So I'm going to combine my like terms first. And then I'm dividing by 2, so I get that x equals 12. So I'm not done yet. It asked me to solve for angle GJK. So G to J to K would be this inside one. So how could I get that inside angle measurement? Well, if I know what x is, I could substitute it into this equation right here and get this angle measurement. So I'm going to do that first. So 7 times 12 minus 16. So that'll give me 68 degrees. So this angle in here is 68 degrees. Let me get the eraser. Get that out. So this is 68 degrees. So remember, the angles of a rectangle are 90 degrees. So if this one is 68, to figure out that light red, whatever color you want to call it, angle, I want to subtract it from 90. So I'm doing 90 minus 68, which gives me 22. So GJK is equal to 22 degrees. So I used the alternate interior angles, and then the fact that the angles of a triangle, the angles of a rectangle should equal 90 degrees. So let's move on to our last problem then, number 13. Okay, so 13 is the same type of thing, it's just a little bit different. So if you notice, these two angles aren't on opposite sides of the line like 11 were. But if this angle right here is 2x minus 3, I could say that this angle up here is also 2x minus 3, for the same reason that I was able to set those other angles equal to each other, because these would be alternate interior angles. So then we know that this whole angle V should equal 90 degrees, because a rectangle has 4 90-degree angles. So these two parts added together should equal 90. So I can say 5x minus 12 plus 2x minus 3 should equal 90 degrees. So those two angles are complementary angles. So again, we're going to combine like terms first to solve. So we're going to have 7x minus 15 equals 90. Divide by 7. So that we get x equals 15. Okay, so let's look to see what angle we're trying to find. So it says VWZ. So remember, V to W to C to Z. It's talking about this inside one. So how could we get that opposite angle? Well, we can figure out this angle measurement, right? Because it would be 2x minus 3. And then remember that since these sections of our diagonals are the same, this is an isosceles triangle, so our base angle should be the same. So if I figure out what V, the one part of V is, so WVZ is, I can find what the angle is they're asking us for. So I'm going to substitute x into 2 times, I'm going to substitute 15 in for 2 times x minus 3. So that gives me, I substituted it basically in so that I'm looking for XVW. So I found this angle in this teal color basically first. And I found that it was 27. And then since these are base angles, they should be congruent. So my answer ends up being also 27. So that might be a little confusing as to why it's also 27. But hopefully you can see that since the diagonals are the same, that this forms an isosceles triangle. And we can get this part here that I'm circling because it's 2x minus 3. So a lot of times with these problems, what you have to do is kind of see a pattern or see a relationship, kind of how you can relate things together. So like for this one, you have to be able to see that to set up some type of an equation that you could make alternate interior angles. And that helps you set these equal to 90, and then you would have an isosceles triangle. So a lot of these take practice getting used to. So you have to make sure that you're actually doing these problems so that way you can get into the hang of how to set them up. So I hope this helps. I hope everybody was able to get whatever they needed from each of the problems. Again, if you ever need more help, if watching the problem you still have some questions, you can always come in during Monica morning or during my help hours after school. Thank you for watching Math After Hours. Have a good night.